Hi there, my name's Vince from mymatevince.com, and in this video today we're going to try and fix these Belkin Powerline adapters. So these were sent in by a viewer called Sid, and he thought it would make an interesting video because they need to work as a pair, yet one isn't working, yet they are the same. So I'll be able to get the comparison from one to another, and I might be able to pinpoint the faulty component. I agreed that it would make an interesting video, hence the reason they ended up on my blue mat here. Now, as you know, I don't normally accept donations, but in this instance I did because they were only going to be thrown away anyway, and I just thought it would make an interesting video. Whether I fix them or not, Sid does not want them back, so I've got nothing to lose, and at least this way, if I don't fix them, I can still harvest maybe a few spares out of it. So what happens is, one of them does liven up and the other one shows no life at all. So if you have a look, can you see this one here's got a green light and then the bottom light's flashing while this one's not doing anything? So this is trying to communicate with here, but it can't because there's no life in this one. So we need to take apart this one and see if we can see what is wrong with it. And then if I can't, I'll take apart this and we'll get some readings. So basically what Powerline adapters are, if you have a room in your house that has a poor Wi-Fi signal and you can't physically run an Ethernet cable, then you can plug your Ethernet cable into here. It will then run down the actual electricity cables going all throughout your house, and then you plug this into the room where you want your signal to be, Ethernet cable out of this one here into your PC or your laptop, your Xbox, PlayStation, Smart TV, etc., and then you should have quite a stable connection depending on the electricity wiring in your house. Now, a few things to be careful of is sometimes companies will advertise them as 500 megabits, but then if you have a look at the specifications of the port, it's only fast Ethernet, which is 100 megabits. So yes, they're not lying, they are communicating with each other at 500 megabits, but you can't get 500 megabits by the only thing that you can plug into, which is an Ethernet cable, because some of them have only 4 wires wired up, and that's only ever going to be a maximum of 100 megabits. So it's a bit of a kind of sly marketing term, isn't it, to say that they're 500 megabits even though you're never going to get that. Now look in here, we have 3 screws and a blank in one here, so I presume there's going to be another screw. That must be a security thing, so I'll probably have to break through that. But let's undo these ones and let's see what's happening. Now Sid hasn't taken these apart before, so I'm going to be the first one in here, so I'm hoping it's going to be quite interesting. What I'm thinking is we've got 240 volts coming in and it's a pass-through, so I'm thinking there must be some sort of fuse or something in the circuit that separates the Ethernet, because otherwise I could put a kid or me could put my fingers in here and you could get 240 volts on here if a fault was to develop. So I'm wondering if it's going to be as simple as maybe a fuse. I don't know. I've never been in these before. I've never even watched a video on them before. So please do not copy what you see in this video, because remember, 240 volts is more than enough to kill you. So let's see now. Okay. Excellent. So that's not an actual, it is just 3 screws. You don't need to break into that. So what have we got here now? What have we got here? Got to be careful in case there's any big capacitors or anything in here. Oh, this is going to be pretty interesting. Right, well look, we've got the 2 points off the plug going in here. I mean, I can't see anything obvious on that side of the board there. I'm really looking forward to this one. So now, is this going to come off here? How does this come apart? Okay, can you see here we have little pins to pull it apart. So let's undo that there. That comes off nice and easy, doesn't it? So now, would this be like the high voltage side and this like the low voltage side? This is going to be interesting to see what the difference is between the two. I'll tell you what we're going to do. I didn't actually try this. Can you see there's a reset button here? I wonder, do I have to plug it in to do that? Maybe I should plug it back in, do the reset button quickly. I'll just fast forward through that, just in case it really is as simple as a reset. I'm holding down for a couple of seconds. Right, so you can see it hasn't done anything, so it's still dead. It was worth doing that just in case. So now let's unplug it again. Let's get back into it. Right, so these are bent over there, so I suppose there's a chance that these are not making a contact with here, but we can easily check that by just going onto the front here, can't we? So I can just rest that. I can rest that against there and we can just do a quick continuity test. Yes. Yes. Yeah, so I presume that's going to be okay because this thing here is going to be forcing down these bits. So there's no reason to say, well, that's not working. So it could be a problem on this board here, or we might have a problem on this board here. So let's take this apart, see if we can see anything obvious on here. Because this is the one with the little lights and everything on. Oh wow, look at all the chips and everything. I wasn't really expecting that. But I suppose, yeah, these are what's communicating with each other, aren't they? Because normally with these you can have numerous different ones dotted around the house. Well, what I'm thinking is take apart the other one and then swap the boards over. So put this one on the other one and then see what happens. Then we know whether the fault's on here or here, because right now I can't see anything, you know, nothing's jumping out at me straight away. There is a 400 volt capacitor here. I'm just going to make sure that that is actually discharged. So I'm just going to get a reading on my meter. Yeah, that's empty. Yep. If I was to take a guess, I bet it's going to be a problem with the power side of the board rather than this side. But look, there's no point in making it hard for myself. We've got this one, so we might as well utilise it. And then we can spend longer fault finding just a one board rather than having to guess which one it is. Well, I suppose what we could do is, look, that's the fuse here, T2A. Should we quickly check the fuse? Let's just quickly check the fuse, see if we've got continuity here. Because that's what I initially thought it might be. There you go, it's the fuse, isn't it? Look. But now, why has the fuse gone? Would it be just, I suppose there could have been a surge on the line. That's it, it's just a fuse. That's what's gone. So if I went from, where am I going now? Would this be going up to one of the live or the neutrals? It must be. Or is it this side? So it's that side there, look. Yeah, so that's going to there, but it can't travel any further. It's not going from there anywhere else. Can't really see where that goes to. Right, so I suppose just to make sure, well, we don't need to, do we? We don't need to. The fuse is gone. That's why there's no power here whatsoever. Now, I haven't got any T2A. It's just a T2A 250. Oh, we can see a burn. Look at that. Can you see the burn there just underneath it? Look, let me try to get some tweezers and see if that burning will come off. So now there could be something wrong with it that caused the fuse to blow. But what I'm thinking is, it's more likely that there was a surge maybe in Sid's house and that possibly this got it. Look, can you see here? There you go. See, it's starting to disappear. Yeah. Right. Let me. I know I got some PlayStation fuses. They were different than these, but just to see if it's working. So this is a T2A. So this is going to be a 2 amp fuse, isn't it? Let me see if I've got anything. Right. So I found one off a different power line adapter. It is slightly on the high rating, so this is 2.5. There you go. This is 2.5 while we need a 2. I just took it out of this power line adapter here, but I have ordered up 10 of them from RS for next day delivery. They were, I'll double check, I think it was 40p plus VAT or something. I think it was just under 50p each, so I've spent around £5 for 10 of them. But look at this. Obviously I don't want to waste this fuse because ideally I'd like to put it back in here, otherwise I've got to buy another 2.5 amp one for this one because I've bought a 2 amp for this one. But check this out, that side of the fuse goes to here, yeah, but look, that side of the fuse goes to here. I don't think that's right, but let's just double check because we have a working one here. So let's take this one apart now and let's just see if the same thing's happening on here, because remember, we don't know if that fuse has blown from something on the outside coming in, or is it something on the inside that's made that fuse blow. I don't want to blow the fuse unnecessarily, because then I'll have to buy another 10 of them just to fix this one here, the TP-Link one. Alright, so look. Can you see? That's the fault. So with this one, we've got it going to this prong here, yeah? And then it goes through the fuse. But look, it's not shorting between here and here, yeah? But with this one, it will be shorting between here and here when we bridge the gap on the fuse. If I was to get some tweezers to bridge the gap on the fuse, yeah, so let's pretend the fuse is intact. So it's not just the fuse, something's caused the fuse to blow. Look, we've got a short. There we go, yeah? Not good. And it's definitely on this board here, isn't it? So now we have to work out what it is on this board here that's causing that. So something's gone. Something is short in here, isn't it, to ground. This is more interesting now, isn't it, than just changing a fuse over. Right, I suppose let's go across a few things and let's see what. Let's go across a few things and let's see what's happening. So we know this side here should be going to here, so that's correct. But this side should not be going to here. So let's just go from here. Let's go across a few of the capacitors. Right, so we've got a short across this capacitor here. Hold on now. Do you know what? Let's compare it to this one here. Where was I there? So we shouldn't have a short there, so I suppose it could be that, could it? What else we got? What's likely to go in here? Could be the diode down the bottom. That's going to be one of those high voltage ones, I bet, that you need a special tester for. You know, like the microwave one. Let's just see. Oh no, we're getting a reading that way. Then it goes nothing. Nothing. I bet it's the same on this one. Yeah. Or at least. Oh no, hold on. Yeah, I think those diodes are reading the same. I can't see any bridge rectifier here, so would that be the whole, would this whole thing just be DC then? This whole rail here is shorting. I wonder, should I start kind of taking a component out to see what's happening. If you have a look here on a 40 board, yes, 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 and obviously down here as well. And that's not happening on this one. So there is a diode there. Let me just check that diode. I think it's okay. Right, well, I think I might take off this capacitor here, this one here, and also that blue one, that blue whatever that is above it. Right, so that's that out now. I'm presuming that's a capacitor. Right, let's see what's happening now. Right, so both those ones are still short in here. Yeah, let's take off some more components rather than testing all the time. I'm not sure what this blue thing is here either. I mean, that looks like a little ceramic capacitor, but it's labelled up RV1. I'll have to Google that. But that also looks like it's going across both of them. I think I might do that one next. Now, let's see if it's still shorting. Yeah, it's not that. Right, okay, so that's two components I've taken out, and it's nothing to either of them. Ah, there's so many of you that probably know what it is, but I don't. I mean, what is this thing here? What is this thing here? I suppose I could measure it against this one, see if I've got anything that's different. Yes, that's not short in there, but this one is. Well, let's take out the next capacitor, which is this one here. That's that one out. Let's see now if we've still got the short between everything. Yes, we have, so it's not that one either. Well, I've got a feeling I'm going to end up taking off the whole board here. Right, I think I'm going to go for that weird looking transformer thing. No! Oh, I thought that was going to be it. No, still shorting. Oh, come on, what is it now? What else we got left? What else could it be? Everything looks fine. What's left? Hold on now. Right. Well, that resistor there, because it's in line anyway. What is actually left now? Let's go across. Right, could it be this little component here? Because the tracks go down to here, they're shorting. Kind of removed lots from here already, haven't we? But look, that's still, so I suppose if that component was shorted, it could be that. Because that's not happening here. Yeah, see, that's on the other side of the board. That's not through hole here, that's on the other side of the board. I have to get some hot air on that. Right, let's see if the shorts have gone now. Yes, they have. So, hold on now. Let's go on to here. Hey! We found our faulty component, whatever this thing is. Yeah, look, they're not there anymore. And let's turn it over. And now can you see all these points here have gone. Now I'd love to know if there was a quick way to do that. So if it was like a low voltage thing, I know you can, with a power supply, inject voltage into it and see what warms up. Now this is a short here, so it would have warmed up here. But this is all high voltage, isn't it? So how would you fault find that different than what I did there? Because obviously I've had to take off numerous different components in order to get to prove this one here. And all of those components, as far as I'm aware, were going across both lines as well. You know, all of these ones here. So these coils could have shorted, capacitor could have shorted, that could have shorted, or whatever that is, could have shorted. I'd love to know if there was a quicker way to do that. Right, okay, so let's zoom in and see exactly what this thing is. Well, let's first of all see what's marked up on the board as. Okay, so it's marked up as D2, so it must be some kind of diode. Let's zoom right in. Right, so here it is. Here we've got a negative and a positive, and it says MB6S. So I'm going to Google that now, find out what it is. Really, I jumped the gun in buying those fuses. I should have just held on until I did all the testing. I just thought it was just going to be a simple little fix like that. But once Google had the answers straight away, as soon as I typed in MB6S, it came up. And guess what this is? It is the bridge rectifier. Now, I remember earlier, I think I mentioned bridge rectifier, but I don't think I said what I thought. I thought when I seen the short there, that is it a bridge rectifier? Because that's the thing that takes in the AC and then puts out the DC. So they're going to be, well, they shouldn't be in contact with each other, but if it fails, then the diodes in there could short and then put AC onto the DC and short the negative and the positive. So I was thinking that in my mind, but I couldn't see any bridge rectifier in here. What I'm used to with bridge rectifier with my little experience is things in the PlayStation 4, they're this kind of shape, and then they would have 4 little prongs coming out of them. Well, this has got 4 prongs coming out, it's just in a slightly different package. And if you look at this one, it does say positive and negative as well. So now I can buy them from RS Components for about 50p, and I have to buy 5 of them, or I can buy them on eBay for, I think it's about £2 for 3 of them, so it's not a lot of money. But before I buy them, I don't know that other things haven't gone. So did the bridge rectifier fail, which then knocked out the fuse, or did something else fail, which knocked out the bridge rectifier, which then knocked out the fuse? For example, is this chip down here faulty? So what I've done is, I had a look at my little TP-Link one here, and this also had a bridge rectifier with the same mark, well, nearly the same markings as MB6, and then I can't read the next one there. But what I'm thinking is, for testing, this one here is 600 volts. I bet you it's going to be pretty much the same. This is only temporary, just to test. And then if it works, then yes, I will buy a fuse and a bridge rectifier. If it doesn't work, then I might not take it much further. Just for purely the testing to see whether I should buy it or not, I'm going to put the bridge rectifier from the TP-Link in here, and I'm going to put the fuse from the TP-Link in here, and then we'll put it all back together and see if it works. Now, I have put all the components back in it again, the capacitors and stuff, and I've cleaned it up as well. So what I'm going to do is I'm going to put this in here. Now, interestingly, They have got positive and negative marked up on here. Let me just zoom in and show you what I've got. And I think even if the markings weren't too clear, I think there's a little notch to tell you which side is DC. So if we have a look, this is the one from the TP link, and look, can you see here there's a notch and it says negative, positive, and this is the one from the hold on, this way round, sorry. This is the one from the Belkin one. And if you have a look again, can you see we've got like a notch out of this side here? Can you, there you go, look at that nice and clearly. So it looks like the notch must signify the DC side. So this is DC, and this is DC, and this is AC, and this is AC. And again, if we have a look at our good board, working board here, this is going to be the AC side, and this is going to be the DC side. Yeah. So if you have a look closely there, you can see there negative and positive. So it looks like everything after this is DC and everything before is AC. And that's why the reason, well, I suppose nothing was shorting after it, because this must, do you know what, I didn't actually test whether this was shorting on the AC or the DC. I'm presuming it's only shorting on the AC. Let's have a look. Shorting on the AC, but not on the DC. There you go. So that's why I didn't have shorts on the bottom capacitors, but I had shorts on the top ones. There you go, look. Excellent. Okay, so that makes more sense now. So if that had shorted on the DC as well, that would have been a real headache, because how would you know? I suppose if you knew that was a bridge rectifier, it's always best to break it down there first, because then you're testing AC or DC. Do you know what I mean? If you get the bridge rectifier, you're kind of halfway, maybe not halfway through, but you're a third of the way through the circuit, aren't you? So that would be useful to know. Right, okay, let's pop this one in, and let's pop the fuse in, and then we'll see if it's going to work or not. That's the fuse back in now, and also the bridge rectifier. So let's just check the fuse. Yeah, and now let's go across a few things. Right, so can you see now we haven't got the short anymore? Yeah. Do you remember before all these things were shorting? Remember this rail here was all shorting? This one up here, yeah? No, it's not. So let's pop it back in its case, and let's see this time now if it livens up. Right, here we go. So this is the good one here, and this one is the faulty one. So let's see what happens now. Let's just make sure the good one's still working fine. Excellent. Lights are lighting up here. Yeah. There you go. Now let's unplug that one and let's plug in this one here. Wait for the bang. Slightly apprehensive. Come on. Yes! Excellent. Green light. Look at that. Is it going to do the flashing? Yes, there you go. Exactly the same as the other one. Brilliant. Okay, so it looks like it was a fault on the bridge rectifier, this tiny little component here, and the fuse. I think what's probably happened is the bridge rectifier has failed, which has then blown the fuse because it's shorted the neutral and the live together. So now let's actually get it working in a real life example. So I'm going to plug one in by my router, and then maybe bring a laptop or something upstairs and plug the other one in there, and let's get it working properly. And just to show you earlier, remember I said about the Ethernet port being different? Well, look at this one here now. It's a 500 kit. So you think, brilliant, you know, like it's 500, look, up to 500 megabits per second. But check this out. Look what it says on the actual box, right? This is the theoretical maximum channel data rate. Actual speeds will vary with network conditions such as distance, quality of electrical wiring and electrical noise caused by other appliances. That's all fair enough. This is the bit that's naughty. The data rate of the Ethernet connection is 100 megabits per second. So these are not wireless, okay? Well, look, okay, forget about the Belkin ones. These ones here, yeah, these are the BT ones. So these are not wireless. So how can you possibly get 500 megabits out of them if the port itself is only 100 megabits? Do you see what I'm getting at? So that's wrong. Those ports there should have been all wired up with all 8 pins. They should have been gigabit ones for them to work with, you know, up to 500 megabits. I'm amazed that they can actually get away with that. I mean, who says that's okay? It's kind of like saying my car can go 200 miles an hour, but yet the tyres are only rated to 50 miles an hour. Do you know what I mean? It's not right, is it? So although the car itself might be able to go 200 miles an hour, your tyres can only go 50 miles an hour. So the fastest you can go in your car is 50 miles an hour, not 200 miles an hour. So I think that's just a bit naughty. Right, anyway, let's get this. I'm going to show you the RS components, how much they cost, and then I'll set this up. Right, so these are the RS components. This is the one that I've actually bought, these ones here, and as you can see, they're 250 volts, 2 amp, and you can see there that that's the same. Very cheap, 52p each, but you do have to buy 10 of them. So I paid £5.23, I think it was, but that was with free postage. Now the one I haven't bought yet are these MB6S, and as you can see, there's loads of them here. I think the ones I need, I've got to double check the sizes. I think I need this size here, the 4-pin SOIC, and it looks like these are the ones I will need. They're only 23p each. They cost next to nothing. This would be excluding VAT, but I do have to buy 25 of them. So let me just click on that. See what it's going to be. So it looks like for 25 of them, I'm going to be paying £5.97. So yeah, I'm actually going to end up spending quite a bit of money to get these working. But remember, I'm going to have 24 of these left to do the other repairs. So you can see that I actually got this item working for under £1, which is really good. And if you look at the model number, is F5D4079 Surf Powerline, and that's what these ones are here, the F5D4079. So it looks like they've been around for quite a long time. I think there was a YouTube video that was done in 2012 or 2013. But if you have a look here, you can see that it has up to 200 megabits per second bandwidth over standard home power lines. Now, I just want to know what that little because there is up to with a little asterisk next to it. I just want to see what that is actually. Yeah, there you go. And it says here, the standard transmission rate, 200 megabits per second, is the physical data rate. Actual data throughput will be lower. So I would say that these are going to have just a fast Ethernet port on them. I would think that this is going to be the same as well, especially given the age of them. So yeah, let's now set them up. So there we have it. Look. 3 green lights, so it's synced up straight away. That was no problem at all. I've got the other one down by my router, and currently I am upstairs. Yeah, so I've done a speed test. I'm not going to show it to you because it's got an IP address on it. It was 25 down and 21 up. Now I have a 350 down and a 30 up. So you can see in my instance here, this is definitely not a good option, but I've got a 1970s house and the wiring in most of it is aluminium. If I was to move this into another part of the house, like for example the kitchen to the back room, then that's all newer wiring, that's all copper, so it would be a lot quicker on that. But still, it is completely usable. I mean, 25 down, so watch this now. On the BBC, let's just go to Google. You can see it's quick enough, but if I was to run a proper cable, then I would be getting, you know, the full 350. Well, I don't always get 350. Sometimes it can vary. So you can see now it's loading up there. Yeah, so it's not the quickest, but again, it does work. My mate Vince there you go, not too bad. There's my trying to fix the microwave. So definitely, definitely usable. Let's go on to the microwave one and let's see how quick it loads up. Skip ads. You don't have to skip my ads though, that's how I make money. There we go, yeah? So you can see, fully usable.
I'm going to try and fix my own microwave oven.
Excellent. Well, do you know what? I really enjoyed that one. I wish I'd got to the bridge rectifier first, but I now know for next time. You see, I'm always unsure about different things like that, but it will come with experience. Thinking about it now, of course it's going to go from AC to DC. But at the time I was sort of thinking, oh, I wonder could it all be AC? But that's just lack of knowledge, you see. So now if I ever come to do one of these again, and in the future I might well do, I know to break it down at the bridge rectifier, and then you see there's going to be a lot less fault finding. In this instance here, if I had broken it down at the bridge rectifier, I would have found the fault straight away, and then I wouldn't have had to undo two capacitors, that other blue thing which I'm not sure what it is, and that little transformer thing. But never mind, I got there in the end, and yeah, I enjoyed doing it, and I hope you did too. So if you did, please give it a thumbs up. Big thanks to Sid for sending this one over, and I've got plenty more trying to fix videos in the pipeline now, and I've still got some that I've actually done. I just need to upload them onto YouTube. So I hope everybody is keeping happy and keeping well. Until the next time, I will see you then. Take care. Bye now.